Wi-Fi 7 supports amazing speed, but a major complaint from people is the ridiculously short range. For 6 GHz Wi-Fi band, if you compare it with 2.4 GHz or even 5 GHz. In my lab environment, I have a UniFi E7 access point, and in the Wi-Fi settings, I have two SSIDs defined, one for 5G. You can see it's only broadcasting using E7, and it's only using 5G Wi-Fi band. For another one, for 6G SSID, similar situation, is only using E7, only using 6G instead. If we go to the device setting for E7, for radios, you can see, just to simplify the comparison, I put them to the narrowest 20 MHz channel width. For transmit power, I set them both to high, and then for channel, for now, I simply let the system manage that, so they are both in auto. Based on this type of setting, let's see what's the current signal situation for the two different SSIDs. If you put your computer very close to the AP, you can notice, okay, for 5G, it's extremely good signal. For 6G, it's good, but not as good as 5G. Still, it's a very working signal strength, right? However, if you move your computer just a little bit away from the AP, not very unreasonable distance, still within the regular range you think. But see what's the situation? For 5G, it is still showing green signal. It's still usable. But for 6G, see what happened? It's lower than -75 already. Almost unusable. Why is that? Of course, we all know because of the frequency changes, naturally it will lead to smaller range, right? But that's not the only reason. Another important factor is the transmit power of your AP. According to this Wikipedia article about Wi-Fi 7, in the year 2020, FCC allocated the 6 GHz band for Wi-Fi use. But at that time, 6 GHz was already occupied by incumbent users, such as fixed satellite providers. So FCC imposed some very significant restrictions on the Wi-Fi devices that will be transmitting in the 6 GHz. Let me SSH into E7. Let me use IW command to list the current Wi-Fi devices. So we should be able to find the device names for 5 GHz and 6 GHz. You see the SSID for 6G, right? So ATH5 is the device name for 6G. Then ATH2 has this SID, so it's for 5G. First, let's try ATH2 for 5 GHz. You can see the TX power, transmit power, is 24 dBm. And in left side for UniFi network controller, for the E7 information, you can see for 5G, the transmit power is 24 dBm, right? So we see the same result. Then why there's another number for EIRP, which stands for effective isotropic radiated power. It is a combination of the transmit power and the antenna gain. It provides a more comprehensive measure of the total output power. For E7, the antenna gain is 6, so that's why the final result for the EIRP is 30 dBm. Then let's see for 6G, what's the huge difference? See, the TX power is only 12 dBm, and it's the same information shown on the UniFi network controller. Even you consider the antenna gain is only 18. So that's why from this example Windows machine, you can see for the exact same access point, the exact same client, just because one is 5G, the other one is 6G, the signal strength is dramatically different. The low transmit power situation really makes Wi-Fi 7 useless in many scenarios. To resolve it, AFC was introduced. If you go to Ubiquiti's store page for E7, you can see this feature, long-range 6 GHz performance with AFC. AFC stands for Automated Frequency Coordination. AFC is a crucial component for enabling the widespread use of the 6 GHz band for Wi-Fi. It provides a balance between expanding Wi-Fi capabilities and protecting existing spectrum users. If you go to UniFi Network Controller for E7, go to Settings. You can see this feature is hidden in this fancy name, 6 GHz extended range. This is for AFC. If we enable it, accept the term of service, apply changes, give it some time. This is the current transmit power for 6 GHz. It's increased to 24 dBm from 12 dBm. And from the Windows client, you can see now the 6 GHz even has stronger signal than 5 GHz. You can see the significant improvement when it comes to signal strength, right? Let's go to the backend to understand how this feature is implemented. SSH into E7. At this moment, we already enabled the 6 GHz extended range in UniFi Network Controller for E7. If I go to TMP folder, I can find these two files, AFC request and AFC response. These two files reveal the secret process for E7 to connect with the AFC server and then get the available spectrum inquiry response. Let's look into the request first. Let me VI the file. This is the API request in JSON format. It is for the available spectrum inquiry requests. It has 4 major sections. The first section is for the device information. It has the serial number, the certificate, and the device model. You can see here the internal model is called SWX-E7. For this particular access point. Then the second section is about the location. It includes not only the longitude, latitude, but also the elevation information. Then whether it's for indoor or outdoor, because that's important for AFC to return what type of transmit power is allowed. Then the third section is the inquired frequency range. So you can see here this E7 is querying 2 ranges for 6 GHz. And then the very last part is the inquired channels. It will request information for different so-called global operating classes. And then for each operating class, it will list out all the channel numbers this AP is interested in. So this is the example AFC query sent out by E7 just because we enabled the 6 GHz extended range. This is a request used for a API call. So you may be wondering, where is the API server? How the E7 communicate with the API server, right? So let's look into that. Let me show you a script used by E7. It's under USR SBIN. It's called afc.sh. I will simply go to the API call part. See this case logic. If it's US, it will call this URL. You can see AFC server is provided by Qualcomm.com. I believe it's because E7 uses Qualcomm chip. And if it's Canada, it will call another URL. If it's other country, unfortunately, it's simply not supported at this moment. Okay, so this is how E7 will call the Qualcomm AFC server to get the information it requests if we enable the 6 GHz extended range on the UniFi Network Controller. Now it's time to look into the response file to understand how it will impact the transmit power. Let me show you the AFC response file. So this file only has two sections. We provided a list of frequency ranges and then a list of channel IDs for multiple global operating classes, right? So the response is specifically about those two sets of questions. So the first section is about available frequency information. So you can see it starts from here. For each very narrow range, it will give you a max PSD value. From the UniFi network controller, for overview, you can find out the EIRP value for a particular Wi-Fi band, right? Then what is PSD? So in the interest of time, we won't talk about the details about PSD. If you are interested, this is an interesting article you may want to read. PSD stands for power spectral density. In this article, the author explains what's PSD, how it's related to EIRP, and then what's the benefit to use it for 6 GHz Wi-Fi band. Okay, then let's move on. Then the second section for each channel was the allowed maximum EIRP. This will directly impact how the AP will decide the transmit power. So for example, in our current setting for 6 GHz, we specify the channel is 133, right? Let's try to find out what's the Qualcomm's AFC server response back regarding 133 channel. Let me find 133 here. The return value is 36. The answer from the AFC server for 6 GHz 133 channel, the EIRP setting is 36. So which means for this particular AP at my particular location at this particular moment, it's allowed to transmit in 36 dBm EIRP. For E7 access point, if we go to technical specification, you can see what Ubiquiti specifies. For max TX power, for 6G, maximally 24 dBm. If you enable the 6G extended range, it will be 30 dBm. Ubiquiti didn't say it very clearly what's this 30 dBm really for, but in my understanding, it's talking about this particular number, TX power, which means maximum number for this one should be 30. If you plus 6 here, the EIRP, I expect to see 36, and 36 is allowed according to the AFC server response, right? But I have never seen a EIRP value greater than 30 dBm here for 6 GHz for this access point. So I cannot relate the result in my testing back to what Ubiquiti specifies. There is one possibility. What Ubiquiti say here, 30, is not about the TX power, it's about the EIRP. If that's the case, Ubiquiti should do a better job to say it very clearly here. This number is for EIRP, not for TX power. Okay, if you have any insights or comments, please let me know in the comment area about the puzzle why here it says 30, and from the UniFi network controller we only see 24, and from the AFC server response we see 36. We have three numbers. Now we have gone through what we can find in the backend about the AFC process, right? So let me use this diagram to talk about that again. So if we enable the enhanced range for 6 GHz on UniFi network controller, the E7 access point will initiate a API call to the Qualcomm AFC server, providing this request information. Then the Qualcomm server will respond back. But how Qualcomm server will get the answer? Qualcomm server will query a regulatory database which is behind the screen, transparent to this Ubiquiti access point. It will happen behind the screen on the AFC server. Qualcomm will query the regulatory database. In the database, the already licensed incumbents, they will put their frequency requirement for a particular location to this database. So based on the collected licensed incumbent frequency information, what's allowed and what's not allowed will be sent back to the UniFi access points. Okay, I hope it's clear. Of course, I don't have any document to get this information. What I draw here is based on my own understanding. Before moving on, there are two things I want to mention. The UniFi access point doesn't need to query the Qualcomm server every single time you make the configuration change, because in the AFC response, if you scroll to the end, you can find a expiration time. It's in UTC. So as long as the response is not expired, the access point doesn't need to query the AFC server again. The second thing is this type of AFC inquiry and response process is not specific to Wi-Fi 7. Instead, it's about 6 GHz Wi-Fi band. You may know for Wi-Fi 6E, it also uses 6 GHz. So this AFC process is also relevant to Wi-Fi 6E. Now let's see the extended 6 GHz range or AFC in action. In my lab environment, I'm going to use E7 as the access point and 3 Wi-Fi clients to validate the signal changes. I'm going to use a Pixel 7 Pro. It only supports Wi-Fi 6E and a regular iPhone 16 and a PC with Intel BE200 Wi-Fi chip. I am going to put the devices at 3 different locations. First, very close to the AP. Second, with a regular distance, not very far away. And the third location is a little bit far away, even for your regular 5G usage. So let's see at the 3 different types of locations what the Wi-Fi signals will look like before and after I enable the 6 GHz extended range. Okay, let's get started. First location, they are super close to the AP. I still have the channel 133 for 6G. TX power is high. At this moment, you can see for 6 GHz, TX power is 12 dBm and EIRP is 18, but for 5G it's pretty strong, it's 2430. So in the right side for the PC, you can see the 5G signal strength is better than 6G, but it doesn't really matter too much. I can use the 2 SSIDs without any problem. And for the Android phone, you can see the signal strength is -30, not the same number as the PC. That's normal because we are talking about different Wi-Fi devices. They have different settings, different hardwares. So of course, from client side, the signal strengths are not the same. But -29 is still very high, very strong. And then last one, the iPhone, you can see the signal strength is -21, better than the Android phone. All 3 clients, they have very strong signal for 6 GHz. I shouldn't have any issue using them. Next, let me keep the 3 clients at the same location and only enable the 6 GHz extended range. You can see the sudden jump about the TX power for 6G is changed from 1218 to 2430. And in the right side for the PC client, you can see for 6 GHz, the signal strength is improved, but still much lower than 5 GHz. For the Android phone, now the signal strength is -20, very, very good. For iPhone, it's -13, still much better than the Android phone. Of course, for this type of scenario, 6 GHz range enhancement is not very useful because the signal strength is already super good before any enhancement. I just moved the 3 Wi-Fi clients. They are not sitting right beside the AP anymore, but they are still in a reasonable distance from the access point. So for the E7, you can see now the 6 GHz extended range is not enabled. From the information, you can see for 6 GHz, the TX power 12, EIRP 18. Then in the right side for the PC client, you can see for 6 GHz, it has much weaker signal, but it's still usable. From the Android phone, you can see the signal strength is not good already. It's barely useful. For iPhone, it has similar situation as Android. The signal strength is -77. It's already showing red color. I just enabled the 6 GHz extended range. Then from the information you can see, the TX power became 2430. It's stronger. The effect is significant because in the right side PC client, you can see 6 GHz has even stronger signal than 5 GHz. And in Android phone, we see similar effect. Now the signal strength is very useful already. For iPhone, it's not as good as the Android, but -71 dBm is already very usable. Next, the very last scenario. Now I put the 3 Wi-Fi clients very far away from the E7 access point. You can see for 6 GHz, I disabled the 6 GHz extended range. Then from the overview, you can see for the transmit power and the EIRP is 1218. Right, the weak one. Then in the right side for the PC client, you can see it has much weaker signal than 5 GHz. For mobile devices, the signal strength is much worse. See the Android, it has a very poor, lower than -90 dBm. It's completely useless Wi-Fi signal. iPhone is not too much better, -85 or 86, still unusable. I just enabled the 6 GHz extended range. You can see for transmit power and EIRP, now it's 2430. In the right side for the PC, 6 GHz has stronger signal than 5G already. Now let's look at the mobile devices. This scenario is where the 6 GHz extended range feature should really shine. For the Android phone, I have -78, 77 dBm. Not perfect, but you can use it. For iPhone, it has similar signal strength as the Android phone, -77. Okay, this is the end of the video. Thanks for watching.